Okay, welcome back. Today we are doing lecture number 2, all about the object-oriented programming, because this is Java, object-oriented programming, Java. A little bit different than C++. I'll go through, as I go through the lecture, I'll try and point out the differences, but don't worry about it if you don't understand any of the C++ references. It's just, I do that for people who have a background in C++, gives them the ability to kind of relate the objects or relate the concepts. And unlike C++, here we go, this is why I said that, because I'm now going to start talking about C++ again. We can program in many different methodologies in C++. We can only program in one in Java. So Java only supports object-oriented techniques. Cannot use a non-object-oriented approach. So what today's purpose is discuss the concept of the object, concept of what entails object-oriented programming, and how it relates to Java, and we're going to look at Hello World, the start essentially of Java. And in C++ and other languages, we have what's called procedures, or we have structures, or we have a top-down approach to program execution, where we start and we write main, if you remember that, if you have any C experience, and then we go from main, we jump to functions and back to main. Everything usually starts at the beginning of a sequence. The beginning, and the flow control is sequential from the start of the program to the end, which is actually the style of what's called imperative languages. So if you want to say, well, object-oriented language versus an imperative programming language. So imperative goes from sequentially from the start to the end of the program, and the routes are by if-then statements and other constructs that are used for flow control. In object orientation, we go object to object, and there is no sequential flow. Although we have a main, and it's the start of what's called the driver program, we don't actually have a line-by-line execution going on. Instead, we make an instance of an object, and then we have the object do something. And then we make an instance of another object, if we want, as many objects as we want. And then we have the objects talking to each other and working amongst themselves. Totally different style, completely different. In C++, you can do both. You can write an old program, old style, imperative language format that uses main and goes and runs functions and does execution of statements line by line. Or you could take the C++ approach, which is supposed to be the instantiation of objects, essentially. So we have procedural. On this example, on this slide, it says procedural. Could be imperative, could be procedural, could be sequential, any way you want to essentially define it, versus object-oriented. So the unit of the procedural program is the function, normally, and the unit of the object-oriented program is the class. A function is not a class, but the function concept comes up because functions are part of the class implementation, but they're not called functions anymore. They're called methods or messages. Most people would call them a method. And they're implemented inside of the classes, and the classes themselves are self-contained objects. They're not functions. So there's a little bit of terminology going on there. Also, the concentration in an imperative environment is on creating functions, while in the object-oriented environment, it's about creating a hierarchy of classes and isolating the classes and then looking for methods inside of the classes. So we'll be making classes today, showing you examples of how to do that, which turn into objects. So in a non-running program, when we are creating objects, we are writing classes. And the class is the terminology that you use in the source code. And while the program is running, the class turns into an instance of an object. So we have one class. We might think of it as a template. It's kind of like C, C++, when you write a function. And you know, well, here's the function. But when you call the function, you have the function work, and the function actually performs something. Same thing in Java, C++, object-oriented world. We write a class, and then when we make an instance of the class, we're actually calling the class, and we're making an object out of it. So objects don't exist until the program actually starts running. Then we have objects that come into existence. So let's see, we can look at the methods inside of the class for the behavior that the class is going to perform. And we have a separation of the data from the program and the operations on the data in the class, where we don't actually have that We We have it. We have it in C, C++ in a non-object-oriented fashion. We have data. We've seen those before, variables, usually. And then we have like non-data constructs, would be what, flow control, perhaps? You know, like if then, else statements, case switch statements, all sorts of different things. We have those in Java, but the data and the processing of the data is now enclosed inside of the object instead of being out in the main program. There is really no main program. There's an initiating object that gets created that starts everything, which is usually referred to as the driver, but it's not really, I mean, it has a main in it, but it doesn't really have it doesn't work the same as a main. So procedural programming separates the data from the program, from the operations that manipulate the data, while the object-oriented programming focuses on both of them together, and both of them get put into the objects. So at the beginning of your program, you usually create a class, and then you create another class, and then you create another class, and then you create another class, and that's what you're doing. You're not doing anything but creating classes, and which is different, because you don't have to initialize and declare variables and do a bunch of stuff and then write a function and then call the function. Totally. Personally, I think it's a lot easier. Just to create a class, and create another class, create another class. It doesn't really matter which class you create first. You might use somebody else's class. Somebody else may have created a class. You can call objects from third parties, no problem. So it's a lot more flexible, and facilitates reuse. It allows you to kind of just build hierarchies of classes, essentially. So, forgot my timepiece. They haven't installed any clock shit in this building. I'm like, here we go. I was like, something's missing. Oh, there we go. Got it. I'm good now. So the concept of the object and the class refers to the blueprint, as I mentioned already, defines the variables and the methods that are going to be supported by that particular object, and the object itself is an instance of the class. So we can have many different objects where we come up with this concept of the instance. If you're brand new to object orientation, you're going to find this interesting. If you're familiar, you're going to think you're going to get bored at this point, or if you're not bored already, because I'm repeating a lot of basic object-oriented concepts, but I have to in order to get everybody on the same page. So instances are unique variables, but they're not variables. They're objects, and these instances carry their own particular data and their own particular information about themselves. As an example, we have students in this class, and each one of you is an instance of an object called students. Let's degrade you down from people to objects, because in the real world everything's an object. So chair's an object, student's an object, board's an object. So we have two instances of this table. We have one here and one back there. They both look like they came from the same store or the same manufacturer. We have some students. You're all instances. Each one of you has your own separate name, hopefully. You all have your own separate birth date and stuff associated with you as a student, GPA, stuff like that. And then we have variables and objects, information that we can share among all students. As an example, I can say students, class starts at 11. So all students show up at 11. Well, most students. Some students show up at 11. Which would be more of a class level variable that I could set, a time for something, for all instances of all objects to do something. So we have class level control, so I can control all of the instances. And then we also have instance level control, where I can control I can't really control you. You can control me, but I can't control you. Instances where you can either show up or not show up as an individual instance of a student. And all the information is sort of kept separately, and it's all organized. So when you're designing your object or your program, you're designing your objects. You're giving them a unique identity, hopefully. You're giving them states, like present or absent. You're giving your objects identity, state, and behaviors, essentially. Well, what can a student do? A student can take classes. A student can drop classes. A student can turn in homework. A student can do all sorts of different student behavior, which is something that you're implementing inside of that object that is unique to that student. And then we build objects from objects. So we can take a student now and turn it into a grad student, or a student and turn them into a TA, or a student and turn them into a staff person or something, where we're giving another identity to the student and we're building it off of the base of a student. So one of the hardest things of object-oriented programming, and one of the most difficult things when people start learning Java, as an example, how to build the hierarchy. Should you start with a student? Or maybe you should start with a person. Usually you go back as far as you think you need to go and start at that point. Everything in the language is inherited from object by default. So you could start back at square one. This is a human. Now the human turned into a person, or now the person turned into a student, now the student turned into, and go through all the generations if you wanted to. Or you could just start at whatever level you think it would be most appropriate for your application. So the next hardest part is figuring out, well, I'm building an accounting program. How do I make objects out of that? And that's where object design comes into kind of play, and it's a different way of thinking, and it is just nothing more than a way of thinking. It's taking the world and breaking them down into separate objects. So if I had an accounting program, I don't really have that much background on accounting. But actually, let's not talk about accounting. Let's talk about registration. That's a little easier. So we have classes. That might be an object. We have students who might take classes. That might be another object, students. We have teachers that teach classes. There's another object. So you start breaking them out, the components that you might want to build for this program, into separate object components. And sometimes you might actually separate some classes out into separate objects. For example, if I just said, well, we have a bunch of classes. Well, but we have MBA courses, we have computer science courses, engineering management courses, all these different courses. We could create separate different objects for that. Or we couldn't. Or we could just keep information about each class, such as, let's say, department or something, which would give the class identity as here's a play on words. The class identity as a class, so the subject as an identity of a class, but then it would also give them states, like what class, where do you belong? I'm in the MBA program, or I'm in the, and so that's what you're doing when you're programming. You're thinking about how am I going to create different objects out of the world, or the world I'm trying to program, and who's going to hold what information. And you need to hold information in order to keep track of who you are as a class or an object. You have to keep track of what behaviors you might be doing. So, and there's some generally accepted rules associated with that I'm going to go through today as well, in terms of the data and then the operations on the data that you might want to consider when you're designing your program. There really is no right or wrong way of doing it. There are some better methods. And there are some rules of thumb to keep in mind. One obvious one is that objects should only have one identity. So if you have an object that has multiple identities, like the chair could also be a table, and then you have issues, well, they have split personalities. So these objects aren't going to be able to perform properly in the world. So they're going to need to be broken out into two separate objects. Or you might have, a chair that does activities associated with a table, but it's really a chair. That might have an issue as well. So keeping in mind the scope, the identity, narrowing it down, keeping it to a single level identity is another tricky part. Because it ends up happening is people go, oh, I have too many objects. I have not enough objects. Actually, that's kind of impossible to tell until you look at the functionality and you look at what each object is doing. You might have 20 objects in a program, you might only have 2. So it depends on what the nature of the program is doing. So there's no set number of objects you're supposed to create for any particular program. It depends on how you separate everything out. So object is an instance of a class. Each object has a class which defines its behavior and its data. And objects in Java are instances of only one class. Other languages, you can have multiple classes per object. And that would actually define multiple inheritance. Not the case in Java. It's simplified. Makes it easier. Those languages, in fact, this follows through with C++. One class is one object, not multiple. But we have this thing, and we'll talk about it later, called interfaces, which are templates of behavior. A class can have multiple interfaces, and it can extend a class that extends another class that extends another class. But the inheritance is single line outside of the interfaces, and each class defines one object. So it's a single line inheritance, but it makes it simpler, in my opinion. So a lot of people don't like to use templates because they don't understand, or not templates, interfaces, because they don't get the concept. But we'll see some examples and we'll go through a lot of this stuff. So class members. So these are the data. Sometimes referred to, I like to call them data members and member functions. You can call them anything you want. Class members. Class can have 3 types of members. So what are members? That's why I have to call them members, because if you have membership into a club, you belong to the club. So if you're an object and you have members, then you have things that belong to you, and these things all belong to that particular object. Here's some examples: fields, methods, and then nested classes and interfaces, nested interfaces, and I'll talk about those in a few minutes. Let's look at the fields. I hate the word field. I don't like to call them field. Instead, I like to call them data. Field comes from like a database perspective, I think, and I don't think in terms of object-oriented programming and databases. I don't think like that, but a lot of people do, actually. A lot of researchers do. So fields is, kind of the terminology. I call them data members. I don't call them variables. That's a really bad habit to get into, because classes don't actually have variables. Procedural imperative programs have variables. Classes have data. They don't have variables. So data variables, which determine the status of the class or the object, which is going to give us our state. So state might be the elevator's up, the elevator's down, the water's turned on, the water's turned off. So the student's here, student's not here, which is your state. And it just keeps track of information, which is what it's used for. Same way we use variables, keep track of information. But we don't add variables to change variables and pass variables, although we can. It's not really the purpose of them. It's just to track information. Otherwise, we would forget if you were here or not, if your state wasn't recorded correctly. And then we have methods. Methods are interesting, and a lot of people like to call them functions. That would be like calling a data member a variable. It's taking a procedural or an imperative word and identifying an object-oriented term with it. I like to call them member functions, or, actually member functions. I like to do that because it's really a function. I also like to use the word methods occasionally as well. So I like to interchange the words a little bit, only because it makes sense sometimes to call them methods. Other people used to call them, and the word has sort of gone away a little bit, but they used to be called messages, because objects used to pass messages amongst themselves, And one object would ask another object to do something, vice versa. But people didn't like messages, probably for the same reason why I didn't like fields. I don't know. So methods, fairly common, or data members, member functions. So what is that? Those are the functions. So they execute the code. The class built from the statements. It allows it to manipulate, to change the status of the object, to access the value of the data members, and all of the information inside of the class. So by default, just the same as I taught in the C++ course, you keep the data members private, you make the member functions public, and you use the member functions to modify the data members. So we have things like assessors and modifiers where we get information, we set information, we modify, retrieve, change the data somehow through the methods, which is our messages. One class can ask another class to do something. It just runs the method of the class. So the objects are created, and then the objects start exercising their methods. And their methods are their behavior, essentially. And the behaviors are changing their states. And they're allowing them to manipulate the data, essentially. If you do that, then you have controlled world. Because just like objects in the real world, you need to control them somehow. Otherwise, the objects just change the object's data of other objects and stuff. It would be like one student telling another student, "No, your name's not that anymore, it's this." And unless they actually filed the proper paperwork to change your name, they can't do it, you know. So there's a little protection between the objects that need to be created. If you follow the standard methodologies, then you end up getting that protection by default for the most part. We can also put in nested classes and nested interfaces. We could have one class inside define another class, and then another class, and then another class. So Java actually supports this. C++ does. I don't believe you can do this in C++, but don't quote me on that. I have to go look that up because I can't remember. I don't like to nest classes actually. And in C++, I like to separate everything out into separate files, header files, and C++ files. In Java, we just have one file, the .java file. So you don't have to worry about all the complexities of designing the project in C++. Java is a lot easier in terms of the interface. We put all the classes normally in a file, in a separate file, and we call the file by the class name. So it's usually with a .java extension. And actually, it has to be in order to use the compiler correctly. And there's some specifics that you have to follow on that in terms of case sensitivity. And the name of the file is the name of the class that contains it. And if you capitalize the class name, it has to be capitalized in the file name. It's actually kind of picky. And then in each one of those classes that you're doing, you can actually implement more classes if you want. You can nest them. And they end up coming into separate files, which is weird. So even though it's nested, it ends up becoming its own .class file. So if you're not familiar, you're just coming from square one. This goes in a file called pencil, P-E-N-C-I-N, with capital P, .java. When we compile it, we go java c space pencil, the name of the class .java, and it creates what's called a class file with a .class extension on it. And different than C++, there's no exe file. And there's third-party libraries out there that you can create a .exe file, which I think is kind of ridiculous. But it's for people who don't understand the JVM or don't get the concept. And what it is just adding runtime support. Because the .class file is an executable file. It has to run in the Java runtime environment. So I'm going to lecture this week. Next week, I'm actually going to show you, we're going to write programs next week. Because I find it's better to absorb a little bit first, and then we'll see it, and then I'll pretty much go over everything I went over today again, but with source code examples, and then we'll see how it comes together. So bring your computers next week. I know some of you have them today, but next week's when we're going to actually see it hands-on. But until I actually understand, until I actually go through it, it's really hard to do both simultaneously. So I usually go every other week with source code examples. But what you should be doing, and to take a slight tangent in the lecture, what you should be doing at this point is installing your Java. If you haven't done so already, go through the 3 tutorials. You have it all installed already? And some going yes, some going no. I'll give you an extra week just in case. I want it done by next week. So some people, I figured I'd get more new people today, which is why I kind of delayed it by a week. So, but I got the same people I had last week, so I think this is going to be our small class. But long story short, you want to get that done so you can follow along next week. But here's our sample class, and here's our first class. It has an identity. It's a pencil, which is pretty interesting. And in the pencil, the syntax is a little different than it is in the C++ world. If you just came out of my last term C++ class, you notice we had categories where we went private, public, and we listed a bunch of stuff underneath it. No categories in Java. And just the same as we had in C++, you can put this in any order that you want, but people like to bunch things together. As an example, you want to put all your data members. I like to put all the data members up front first, and then you can put all your member functions down below it if you wanted to. You could essentially mix them up if you wanted to, but it makes it hard to read. So when we talk about programming style for Java, the convention is actually, I'm seeing more the opposite these days. I'm seeing the methods up front and the data on the bottom. But I still follow the old pattern with the data on the top and the methods on the bottom. And then I always usually like to start out, because a lot of people say, well, you know, the privates should go first and the publics should go second. Doesn't really matter. You can intermix publics and privates. The interesting thing, though, the difference between C++ and Java is you've got to put public on every single line. You can't just go public colon and list a bunch of stuff. Private colon. No, you got to actually use the keywords on it. Yeah. Actually hit the front lights. Oh, you did? Is there a way of hitting this light? No? Oh. Oh, hold on one second. Oh. No, I like that better. Is it too dark? Okay, good. I like this better too. Easier to see the board, I think. All right, so let's go back to our class. This is what we have in the source code file. In fact, how many people want me to skip ahead and just start compiling stuff? Or how many people want just the lecture stuff? All right, no one's going to answer, so I'm going to do something. I'm going to do what you need to do when you get your compiler installed. Once you get your compiler installed, and I'm on a MacBook, so I can just open up a screen here. Let me just make sure I have it. I don't know. I've removed some. Yeah, good. I have it. Oh, good. I've removed some stuff. So I can make the screen bigger, and I will in a few minutes. But here's the concept of what we're trying to accomplish. We are taking this information, this class here, and I'm going to cut this class here. I'm going to copy it. And if you're on a MacBook, you want to use a text editor that, well, from my HTML class, I have Text Wrangler left over. You want to use Notepad if you're on a Windows system, or Eclipse, or NetBeans, or one of the IDEs. I'm just going to show you this to you with a Notepad. So imagine this is a Notepad window. If you're on a MacBook, you want to use something like Text Wrangler, free. Don't use Text Edit. It's not a plain old text editor. It's like a word processor. Don't use Microsoft Word. Don't use OpenOffice.org. Use a text editor. I'm going to paste this code in here to show you what it looks like. You know what? I think I can probably go bigger here too. Here we go. Look at that. All right. So I took this out of the lecture. I'm going to say I want to see what this class looks like and how to work with this. And now I'm going to save it. So I just cut and paste it. You can actually put, some C++ programs have, put a line, an empty line at the bottom, empty line at the top. I don't think it really matters in Java. It can be sloppier with it. You don't have to have main in here. You don't have to have anything in here. But what we've got is a class that's defined as a pencil. Let me go through the class for you real quick here too. We have some data members here, and we have down here we have a member function. And the member function looks like a function in C++. Let's see. These look like data members. If you're brand new to programming, you're probably going to need to get the Dummies book on Java for Dummies or something, just to learn what variables are, just to get up to speed on the concept of programming. But I'm going to assume most of you have had a programming course before of some sort, if you're computer science majors. But we have we could actually take the public out of here if we wanted to. We don't even need that in there, but it's good practice to put it in there. But if you leave it out, it thinks it's public. So if I go like this, I'm gonna mess this example up just to make a point. I'm gonna take the static out too. Well, I'll talk about static in a few minutes when I go back to the menu, when I go back to the lecture. But I said the string color equals red. Well, that looks just like a variable, doesn't it? It's going to be color. Integer length, it's not assigned anything. So we have our regular variable declarations and initializations going on here. Float, long, and it's the same kind of variables that you'd see defined in C or C++ or Java or any other language. And then down here I've got my set color method. And again, I could take this public out if I wanted to, because by default it's going to be public. So I could say, but it's a good idea to put it in, because we want to say everything has got to be either public or private, because if it's public, it's going to be usable outside of the class. Anybody can touch it. If it's private, it means only items that have privilege inside of the class implementation can touch it, can use it. What I mean by touch, I mean modify, and actually print it out, use it for the utility. But this is any other ordinary function you'd see in C++ or Java, or anything that you're familiar with so far in terms of the functionality. And I'll go through that as we continue with the lecture. But void set color takes on a string new color, and it's a method that can be run from outside of the class. So we would make a new instance of this pencil, which I haven't quite done yet. And we just have this class that we've created. And we would run the method, and the method would set the color, and it's going to set this color here to the new color that we've assigned it. So we can change the color of the pencil to another color. So just to go through the rudimentary part of it, I'm going to save this. And when I save it, I am going to hopefully find a save function. Here we go, save as. Should we put it on the desktop? Maybe I'll put it in bhacker. There we go. And I'm going to save it with pencil, capital P, E-N-C-I-L .java. You actually have to use capital. If you don't use capital, you're going to get an error. So now I have saved it, and I'm going to go back out to my terminal prompt and see where I am. Whoops. Hello. I'm in bhacker, so if I do a directory, I should see pencil. Here it is. There's the class right there. So if I want to compile it, I type in java c space capital P E N C I L .java, and it comes back with errors. What's it coming back with? Illegal character set. What's wrong with that? This is an excellent thing. I'm glad this happened, and I actually kind of forgot that it would happen. This is not ASCII. That's in a special font. When I cut and paste that example out of my lecture, I didn't put it in a standard font. It didn't paste in a standard font. This is going to happen to you a lot. You cut and you see, oh, it works just fine. You cut and paste it off, semicolons, quotation marks, single quotes, double, everything. You got to watch out. So I'm going to go back to the text editor. I'm going to take this and I'm going to backspace over it, and I'm going to put another one in. You see how it changed? You probably can't see where you're sitting. Oops. Make it a little bit bigger. See how the font's slightly different between this one and this one? And I put it in a text editor, and you're going to have the same problem. You're going to put it into Notepad, and you're going to go, what happened? I don't understand. So let's make it smaller so I can see what I'm doing. Alright, so now I'm going to save it again. I'm going to try it again. I'm going to save this file. I'm going to go back out here. I'm going to say java c space pencil.java, and I'm going to compile it. And lo and behold, it should come back with nothing. That's what you want to see. You don't want any feedback. Nothing. If it comes back, great. So you type in ls, and now I have two of them. I have pencil.class, and I have pencil.java. That's my source code file. That's my compiled file. But I just created a class. If I could essentially run the file, but I'm going to get an error message because I don't have a main method in there. I'm going to talk about that in a few minutes. If I wanted to run the file, I would go java space pencil. Interesting thing is you don't type the dot class. Most inconsistent behavior I've ever seen in a language. But to compile it, you got to go dot java. To run it, you just type in the name. No, if you type in dot class, you're going to get an error message. Here's the error message. It's going to say class not found. Yeah, it's not going to be found. But if you type in it correctly, let's clear it out so we can see what this looks like. It's going to go back and say, look, you have no main. You're going to get that error message too if you run the wrong file. So in a few minutes, we're going to create a main program to run this pencil. And when we type in that class, we're going to go through the same process. When we type in that one and we run that, it's going to look for pencil. And we're going to have two different classes. We're going to have pencil.class. We're going to have myprogram.class. And depends on which one we run. So basically the point is you have to find the one that's going to be worked as the driver, which is what they call it. You can name it, my program driver. You can name it main. You can name it anything you want. But that's the class that's going to start everything. And that's the class that's going to initialize and make a new instance of this pencil class to run the class. So let's go back to that lecture. I can find the lecture. Here it is. So let me back down smaller. I'm going to talk a little bit more about the class in a few minutes here. I guess I could do this thing, switch back and forth. Oh well. Alright, so we have a public string, color, public entity. These are different variables or data members that we're doing. We have this word static in here. In C++, static is used to make things constant, so you can't override it. In Java, it definitely has a different meaning to it. In Java, it's used to make a class variable instead of an instance variable. So if we wanted to keep a variable that tracked data among all instances of the objects that were created from this class, we call it static. And we're using a static long next ID because we want to keep a counter of all of the different pencils that we've created. And so we can say on each new instance we can increment the ID number from 0, 1, 2, 3, 4. And it doesn't matter how many instances are out there, this value is going to update for all of the instances. And it updates for everybody in real time. Which is why we're using the keyword static here. It makes an instance variable into a class variable. And class variables can actually be set and run outside of instances of objects, which is kind of interesting as well. And then we have our method that I talked about before, the set color method, that's going to change this here. Common mistake people do is they put in here string color is equal to red, they'll put it inside the method. This is because they've been taught how to do imperative programming. They know procedure. So inside of here, they start using these variables that they've created because they think this is a function. Global scope. So inside of each one of the methods, we have already acknowledged, and we already know about color. Although color wasn't defined inside of this method, we have color outside of the method. So think of the scope of all of the variables as the class. And you can use all of them inside of the methods. And if you do this, you go string color is equal to red in here, and you copy it from here to here, you can do that. It's a lot of work though. Why do that? It's like creating extra variables that you don't really need. So you don't want to use the variables that you already have color here. So you can take color and have it equal to new color, and it's going to set it out here. It's going to use the same color. But that's also going to be another. It's going to be another thing you're going to discover, because then you're going to go, I changed the variable, but you created a new variable. You changed the new one, not the existing one. So that's another thing you'll find out when you start programming. So let's go through a little bit more in detail about the data members and how they were initialized. So the field declarations, when we declared them, this is referring to this concept here. Field declarations, where we said color and stuff. So we have the type, we type the name followed by the field name and the optional and initialization clause, which is optional. As you remember before, I took out the publics. And this is really referred to as the access method. And I did that on purpose to show you that if you leave it out, no problem. Some people just don't want to deal with it at the beginning, so you don't have to. If you did that in C++, you get a complaint. Is it public or is it private? What is it? Java, you can leave it out. But it's not, you don't want to leave it out forever. Eventually you'll start putting it in, make things public, make things private issue. But if something's not compiling or something's not working properly, you can't get it, just take it out and run it and see what happens. And most likely you've got something private that should be public or something. That's what's causing the problem. But it's sloppy to take it out completely and never put it back in. So primitive data types versus object references. Interesting. These are primitive data types that are in the language: double, float, integer, long, short, byte. And the string is actually an object. Everything in Java is an object, unless it's a primitive data type. And primitive data types can actually be used as objects. So just imagine everything, just like JavaScript, if you're familiar with it, can be used as an object. Everything, even variables. the data. Field declarations can be preceded by different modifiers. So I call them accessors, access modifiers. I don't know. You can access methods. You can call them modifiers. But what they're doing is they're controlling the access. So it's for access control. So access control modifiers, static, and final. Access control modifiers are the public and the private. And static creates that class. And I'll talk about final in a few minutes. So here's those private, public, private, all the other stuff here. Access control modifiers. So private data members are accessible only inside of the class itself. Public, or leave it out, is accessible everywhere. If you don't put an access modifier on there, you don't say public, you're just saying I don't care. So it's going to be public. If you want it to be private, make it private. Packages. We can put package out there. Packages I'll talk about in a few minutes, probably not till next week. They are package members. They're accessible inside of classes in the same package and the class itself. So everything inside of the package belongs to the package. It's like being a member of a club or a group. You can speak with, talk with, get the data members of everybody else in the same package. So it's a way of creating access to groups. You put it in a package. You can program forever and not use packages. And then you can figure out, oh, packages come in handy. Because you can put different classes in different packages and use different versions of different classes. And then you just import the package and go, oh, okay. But we'll talk about packages further on. That's a little different in C++. Protected members are access classes in the same package, in the same subclass, or the class, and in the class itself. It's protected only if it's used in inheritance. Same concept in C++. Inherited classes from the class can use it as if it was public, but outside of the class, it can't be accessed. It's private outside and protected inside, essentially. And then public, they're accessible anywhere from the class, that is, wherever the class is accessible. So here we have another component. And the other component we're looking at is our public class create pencil. This is our driver program that I talked about. And actually what I'll do is, before I demonstrate the point that's going to be in here, let me cut and paste it, and then we can complete our example. Oops, let me find it, it's too small. Here it is. Ah, my computer has a mind of its own right now. There we go. So I'm going to go back to my my terminal prompt. Actually, I already have it up, which is good. I'm going to go File, New, Text Document. I'm going to create a new text document. And I can kill a couple birds with one stone here. I'm going to create the driver program. And this one's called Create Pencil. And this is going to give us an error message, so I'm going to go like that with it. Comment it out. And I'm going to check to see if I've got any quotation marks or anything. Actually, you know what? I don't. You know what this isn't going to give us? I took out static, didn't I? No, well, we'll leave it alone. This is going to call Create Pencil. This program is actually going to run because it has a main method in here. This is the same syntax, the same thing you see in C++ that you put in the program. And usually you just have one file in a C++ program. Typically, if you're writing a small program. And there's a main in there, and main has everything in it. And for the purposes of Java, main only has one thing in it, or two things in it. It makes instances of objects, and it runs methods from objects. So here we have pencil P1 equals new pencil. We've just created this object called pencil, and we saved it, remember, a few minutes ago. We have the pencil.class file, but pencil doesn't run on its own. Instead, we create this driver program, which in itself is another object, essentially. And in the object, we only have one method. We don't have to. We can actually put more stuff in here if we wanted to. But for simplicity's sakes, we're just going to create one method, main method, that's going to create an instance of this pencil. And if I wanted to, I can create another instance And the way you create the instance is sort of like the way you create variables. You say the name of the class, pencil, the name that you want to call it, P2, the instance name, and this is going to be equal to new pencil. So this is something you're just going to need to memorize, essentially, because it's just going to be just the format. So every time you say new pencil, new crayon, new whatever object you've created, it's going to create a new instance, but you have to give it a name. So that's where you say pencil of type pencil. So this is really the data type of the object, which is pencil, the name of the object, and then this operator new is what's creating that new instance. So you'd use the similar syntax in C++, actually. But you're not actually using pointers and you're not allocating memory, at least like what you do in C++. When people see new, they go, oh no, dynamic memory allocation of pointers. I hated that topic. Not the same. It's a lot easier in Java. So this one is called create pencil. So I have to save it with the name. So actually I'm going to take a shortcut. I'm just going to copy that name. I'm going to come out here and I'm going to do a save as. And I'm going to put it in the same directory. And I'm going to call it createpencil.java. Oops, if I spell it correctly. And I'm going to go save. There we go. And then I'm going to go out to terminal prompt. If I can find it. Here it is. And I'm going to list things out. I'm going to say, well, here's my pencil. Oh, I create. Oh, did I put it in right? Here it is. Kind of hidden up here. Create pencil. And now I'm going to go Java C space create pencil.java. And hopefully I'm not going to have any errors. I didn't have any quotation marks or anything in there, so it should compile just fine. So now if I type in Java, because create pencil has a main method in there. If I go create method, create pencil, it's going to run, but nothing was printed to the screen because it didn't really do anything. I didn't get an error message though, but it didn't do anything. Instead, what we have here is it just created two instances of an object. It didn't really do anything. So we haven't really gotten any functionality yet. So you're not going to have anything come out unless you do like a system out print, to print out something. I'll go through that next week. Right now we just want to get you compiling, teach you the basic fundamentals of the class today. But if you got an error message, which meant there was no, if you got this, means you're running the wrong program. So this went away when I ran create pencil because I included a main method inside of that program. So let me go pick up where I left off here. Talk about what the slide is going to tell us about this word static that's in here. In our previous example up here, we're running we're trying to set here p1.price. So if you're not familiar with the dot notation is how you get at data members and how you run member functions. And you use the name of the object, in this case was p1, dot, and then in this case we're saying price. Price is right here, but price here is private, which means this is going to generate an error for us. And the error we're going to get is price has private access in pencil. If we run that, and it's not going to let us set the price. And for those of you who are not familiar, this F is going to say, convert it to a float, which means it's going to give you the decimal precision. You don't actually have to put the F in there. You can just say 0.5. Actually, you can say price is equal to 5, and it'll convert it for you automatically. Yeah, this is just showing you that you can do it this way, but you don't actually have to put the F in there. Because up here we've said float price. So we're just going to convert that to a float. If not, it would convert it automatically for you. Yeah. Correct. 5.0. If you say 5, it'll be 5.0. But it might show it to you as 5. The precision is going to be in the format of a float. It'll be formatted in a float. So, which is kind of interesting. If you really wanted it, if you want that precision, 0.5, you could say be specific to convert it. So. Yes?
Will we not include the pencil class in the same program? Because it's just compiled, so it takes.
Whoops. Let's go back. We have it in. Oops. Hello. Oh, that's because I'm hitting minus. Hold on, I'm getting used to my MacBook again. We have the two classes in the same directory. We don't actually have to include one inside of the other if it's in the same directory. Correct. So there's no .h file. There's no .c++ file. There's no include. If you notice, I wonder if this will work, actually. No. There we go. If you notice, the text doesn't even have anything in it. This is all we had, actually. We didn't have any includes, no imports. In fact, we don't even have include in Java. We have imports.
First we have to compile the pencil file, so we know the class file, everything.
Ah, interesting. Watch this. Let's say, for example, we have, I'm going to delete, remove, restore that class. So, whoops, we don't have, what directory am I in? RM. I'm like thinking, too much vacation. Remove star.class. Hello, class. Good point, actually. It allows me to demonstrate something to you. Let's see. We have two files in here. We have, you guys can see this? Is it big? Okay, can make it a little bit bigger. Let's see. There we go. We got two. That's big now. We have two of them in here. We have create pencil and we have pencil. If I want to, all I have to do is take this guy. Oops, this guy here, create pencil, that makes an instance of pencil. It will look for it, and it will compile them both. So I go Java C space. So you notice right now, we only have those two. I just deleted both of the .class files. They don't exist. So now I'm going to go Java C space create pencil.java. It comes back with nothing. Good. And now I'm going to go ls star.class. I got two. So that's why you kind of want to know what the driver program is. Who's got main? If main's making an instance of an object and the object already exists, here's the interesting thing. This is where this gets a little tricky, actually. Let's say, for example, we changed something. We changed the contents of pencil. And we already have a pencil.class. And we didn't remove pencil.class, it's still there. And we didn't recompile it, but we compiled create pencil. It's only going to compile create pencil. It's not going to go back and update our pencil.class. So this is dangerous. So what a lot of people do if they're going to do it this method, they're going to delete all the class files or recompile everything fresh. Otherwise, like right now I could show you, probably I can just explain it and you get the point. But if I go back and change pencil and don't recompile it, the old pencil's going to run. Unless I specifically. So a lot of people will do this. They'll go Java. They'll go Java C space star.class. That does everything. Well, it would help if I got the syntax correct. Invalid pencil.class. Invalid flag. Pencil. Oh well. That used to work. Use help. It's not liking it. Well, you used to go star.class. That's not working with this current version. I did upgrade this recently, so it might work on your older versions. Not working on. Oh, you know why? Star.java. Excuse me. Hello, it's Monday. If I go star.java as I'm supposed to correctly, then it should come back and compile everything for me. There we go. Yeah, you can't. This is FYI. This is wrong. You're supposed to go Java C with the Java files, not the class files. They're already created. We want to get to the class files. That's why I'm compiling. So I left my brain at home today. So
the file is created for pencil and also the create pencil.
Correct, because I did an asterisk.java, which said take everything in this directory with a .java extension and compile it for me. Little safer method than, and it's going to overwrite the class file that already exists. A little safer method than compiling just the main, because the main's going to take and compile everything it needs. So if you're not making an instance of the object in that particular main, it's not going to compile it. So you might end up in a situation where something didn't get compiled, especially if you updated something. Inheritance will compile backwards as well. You can. Watch this. Actually, this will be a test because I'm not sure, actually. Let's see. Let me see, actually. I'm kind of questioning whether the newer... In the old days, you can do this in some of the IDEs. Let's see if you can do it here. Actually, I'm going to take pencil and I'm going to take create pencil, and I'm going to put them both in the same class. I'm going to cut this out of here. It might complain. This is the pencil. Let me close this guy. Where's my other one? What I had create pencil. There we go. Open. So now I have them both, but I put this one first because the file is called create pencil. Let's see, actually. This may come out with an error message and tell me that I need to put pencil into another file. Some of the IDEs allow you to do this, some of them don't. So I'm just going to do a save as, and actually no, I'm just going to, I can always remove it. I'm going to call it pencil, I'm going to replace it. So now create pencil has both in it. So if I go out here, and I'm going to remove the .class files, remove star.class, and I'm going to remove pencil.java. And so I'm going to take a list here. Now I just have create pencil.java out here. And this create pencil, let me just make sure here, that create pencil has both, has pencil and create pencil in there. I believe I'm going to get an error message, but let me just see. Create pencil. If it doesn't give me an error, it'll compile both and it'll create two separate files. So now if I go list star.class, I have the two separate ones. It will always create the separate .class files. This is really poor practice, though. Some of the IDEs, I know Eclipse lets you do it. I didn't know if the command line, well, Eclipse is using the command line compiler, so I guess that should have worked, and it did work. But this isn't what I would call good programming practice. It's much better to put in two separate files. Yeah. Oops. Okay. Any other questions on that first example so far? Good. So let's talk about static for a second. We talked about private. This is the other example here where we set private on everything's public, but we put private here. So this is going to give us an error message. Huh? I'm sorry? String color. We could create a constructor, which I'm going to talk about next week. Same thing we do in C++. We can create a default constructor that initializes everything. We can create multiple constructors. Believe it or not, it's the same concept as C++. It's the same method. It's a method with the same name as the class, taking on any number of parameters, and you call it by running it when you make the instance. So instead of saying new pencil here, we would say new pencil, the color, comma, whatever we had in there, a list of our parameters, and it would call, this is actually calling a default constructor, but we don't even have a constructor, so we don't have to worry about it. If we put a pencil in here, default constructor, this would initialize everything. So you actually bring up a good point. In here, we've kind of set color to equal red. Not very standard, actually. Instead, it would be better to create a default constructor and say color is equal to red. Set all your declarations here and all your initializations inside of a constructor. That way you just go to the constructor and you see everything. Because you get into practice of going, well, what are they initialized to? Well, where's the constructor? If you're looking up here, you're not going to see it. So, excellent point. So let's talk about static for a second. Only one copy of the static field exists. We don't get separate copies for each one of the instances of the objects. It's shared by all objects, however, so everybody has access to it, but we only get one. Can be accessed directly from the class itself. And it can be accessed from outside of the class. It must be preceded by the class name. Here's an example. So we have pencil.nextID. Most people would look at that and go, that's not an instance, that's the class name. So you use the class name dot the variable name that's declared as static. If you did this with a non-static variable, you get an error message. If you do it with a static variable, you get to set the value, or you get to retrieve the value or print the value out to the screen. And this is actually showing another thing that I'm going to go over next week. It's the system I/O, which is coming in from an import, which we're going to see next week, importing a package for I/O, but it's by default already imported, so we don't really have to worry about it. We're not using it in any of our examples yet. But system.out is the equivalent to cout, and printf, to anything you might be familiar with from any other languages. It puts output, and the print line ln actually puts a line return at the end of the line. So we could go system.out.print if we wanted to, and leave out the ln, and then we can go or we could use the end line. There's a lot of different variations of this, and I'll go through that next week, actually. Or you can also do it via, in terms of the example, or via the object belonging to the class. This is the object belongs to this class pencil, which is why we're able to do that. Another actually kind of interesting note to kind of consider is this is capitalized. This is capitalized. By default, it's common standard to capitalize all names of classes. This is a class object, and we're calling from system.out, which is going to give us our method to output, and we're going to do a print line. So we're running a method from a class object, if you think about it. But this is actually static level as well, because we're not making an instance of system out to create a class of it. But you can, which is interesting. So some people create instances up front. They go, create an instance of system out, call it printf. And then you say printf.this, printf.that, and it's like, oh no. It's like they're trying to take Java and turn it into a different language. So I would just get familiar with this, because it makes your code a little bit more readable. People look at system.in, system.out, and they go, oh, input, output. It's kind of like using a type define in C++, where you're changing a float to a double or something, or a Boolean, creating a Boolean from a string. So it's just from an integer. So from outside of the class, non-static fields must be accessed from the object reference. So this next ID that was in here, this next ID from this word static, and it doesn't have to be static long, you get static float, static integer, static anything you want. Anything can be static. Methods can also be static. So it's not just the data members. This next ID actually belongs to the class. It doesn't belong to the instances of those classes. So here we have more information, and I'll let you do this. You can cut and paste this and change your class, create pencil around a little bit, and actually see the output. Here we're doing an interesting kind of experiment where we're taking pencil P1 is equal to new pencil. We've seen that before. It's creating our new instance. Remember, this is our driver program. And then we're going pencil, the name of the object, dot nextID plus plus. Same syntax as C++ to increment. So plus plus increments it. So if it was 0, now it's 1. System out, and then we're going to print p1.nextValue. So we can access it from the instance, we change it from the class. So we change this value from the class because it's static, can only be changed from the class, but we've accessed it from the instance, which means it's not totally hidden from the instance of the objects. The objects know how many pencils there are. They know the current ID. Otherwise, how are you going to use it? How are you going to assign? How are you going to print it out? And here we have pencil P2 is equal to new pencil, making another instance of the pencil. And we're saying pencil next ID, we're going back to the class and we're incrementing it again. So now it's going to be equal to 2 probably. And system.out.println p2.next, print out the second object's next ID, its variable. And then we print out the first one, and uh-oh, the first one's changed too. So it's still 2. It didn't go back to 1. So when we changed the next ID with the second object, the change reflected for the first object as well. So all instances of all objects reflect the change. They're all affected by the static variable at the class level. So that's the tricky part, huh?
Using with the object, right? So
yeah.
How can we have to use the class name dot?
Here's the syntax right here. Pencil. It's not the instance of the object. It's the object itself.
When you are printing it, you are using the object name. How do you?
It's just to show you this is P1's version of the next ID. This is P2's. Each one of them has it. They just can't modify it.
But
They
for
can
all the
access it
instances,
though.
It's the same only one variable.
Mm-hmm.
So we can use it like this with the object name.
Yeah, you have to. If it's a static variable, it's considered a class level. It can only be changed by the class.
Okay, you can just print it out without.
Yeah. You can print out, actually, if it's a static variable and if it's a non-static variable and you do this, you're going to get an error. It's going to say, which instance of pencil do you want to update? Here it's going to say, well, this is a static variable. Okay, so it's next ID of pencil, but everybody has it. Everybody has privilege to looking at it. So they're all going to have the same value of whatever the last person who changed it's going to be. They're all updated automatically. So you can keep track of, in this particular case, we're keeping track of IDs of pencils. So we can know how many pencils as an example. Each pencil that gets created, we're incrementing it. So we can keep track of who. But the pencil itself can't increment it. It has to be incremented from the class level. It's like keeping track of all instances of all pencils. So it's a great way of giving your objects IDs in this particular example, or setting something that's common. Keeping a total maybe of all objects that are created. Something. So note this code is the only purpose of showing the usage of static. This is poor design. This is very poor design. Because we wouldn't be doing pencil.xid out here in the driver. We don't want to do anything in the driver but create some instances of some objects and then have the objects work with themselves. We're doing object behavior, actually we're doing class behavior outside of the class in the main program. We should be doing it inside of the objects. So inside of each one of the objects we can go pencil.nextID++. And we would probably have a default constructor that said, each time a pencil was created, increment the ID and then assign the number to the pencil, essentially. Inside of the class itself, but not inside the driver program. So if you can kind of get the impression that this is sort of sloppy because we're putting functionality out here. And going back to what I said about C++ and Java, we don't have any procedure. We don't go through line by line like this in Java. We don't initialize variables and then increment variables and then make new objects. Well, we want to kind of minimize this behavior and put this inside of the classes and have all the functionality in the classes, just create a couple instances of the classes and let the classes do their thing, which is what's called good programming practice or good design, which is totally different than C++, completely opposite. Final. We haven't seen final in the example yet, but we'll see it coming up. Once initialized, the value cannot change. So it's the final value. Cannot be changed. It's done. Often can be used to define named constants. So we say final value. It doesn't make it static. It doesn't make it protected. It keeps it public, but it makes it final. So it protects it. Like you ever say final pi is equal to 3.14. That'd be a good use for it, especially if you don't want the definition of pi changing. So static final methods must be initialized when the class is initialized. Okay, and non-static final methods must be initialized when the object of the class is constructed. You can probably get the impression of why that would be the case. If you have a class you're not initializing it in the class, and you're making it final, you can't use it. Because once you start the driver program, it's final. You can't increment the value anywhere. So you make it final inside of with the static, you make it final static, pi is equal to 3.14. You initialize it right there as you declare it in the class. For a class variable, you don't actually have to do it in the constructor. You can do it in the class itself, right at the beginning. You don't have to actually put it in a constructor because it's a class variable. It's not for each. It's not designed to be used by each method. By each object that's created. So each instance of each object. Right at the beginning, before you create your methods, you would put that in there. And static variables are inherited as well. So you can have a pencil, and you can have a pencil ID, and put it at the top of your pencil class. And then inherit different types of pencils. We got ballpoint pencils, rounded pencils, long pencils, short pencils, all these types of pencils that can be inherited from them. And they would all have an ID inherited from pencil. And they would be a class variable from the pencil level. So all different types of pencils that were created can share the same ID system. If that makes sense. You'll see how static with classes works with inheritance a couple more weeks down the road. We have to get through the basic object before we start in. But inheritance is actually the first topic we'll hit after we hit the object. So non-static ones must be initialized when the object itself is constructed. On the object instantiation, we assign a value to that final variable so we can keep it constant. Or we could do it before. Doesn't really matter. So field initializations. We've seen some, the dot with the float. Not necessary to be constants as long as they're in the right type. If no initialization, then the default initial value is assigned depending upon the type. And here's the initial value with the type. So we see if we don't assign a value, we're going to get 0 as a float assigned to that float. We don't actually have to say, make it a float. We just did that for emphasis point. You could leave the F off of there if you wanted to. Object references are always null. So if I said pencil space P1, that would be null. And then I said, well, P1 is equal to new pencil. Then that would make it equal to an instance of an object of a pencil. So otherwise it's going to be null before that, which is kind of the same thing you get in C++. In terms of method declarations, method invocations, there's two parts to it. We have the method header, and then we have the method body. So you just go back to what you learned about functions. It's really the same concept. So the method header consists of modifiers, which are optional. Return types, which are optional, because we can use void and not have a return type. Method name, parameter list, and a throws clause that's also optional. So at the end of the method declaration, we could say, void main throws IO exception. And the throws is kind of different than C++ in that the method is actually going to have built-in air handling. So it's air handling built into the JVM. And when you say throws space the name of an exception, I'll have a lecture on this as we go through the course as well. It'll look for and try to catch exceptions and handle it for us, print error messages out and stuff like that. So we have to write our own error handlers in C or C++. We have it built in. So we can actually just say, hey, throw this exception. We're trying to open up a file. Oh, we got to throw an IO exception if the file doesn't open correctly. So we know what happened. Types of modifiers for the access control modifiers. These are different. We have abstract, static, and final. These are method modifiers. And here's an example right here where we've got abstract void sample method. So abstract means that the method body is empty. We use abstract methods in interface classes, which we haven't talked about yet. So let me talk about interfaces a little bit. In C++, we have two concepts. We have the .header, the .h file, which was our specification file, where we have specified that we're going to have this function and that function and this function. And then in C++, we have our implementation, where we have the bodies of all those functions filled in. Java's got the class, which is the implementation file. And then we have, instead of the specifications, we have optional interface classes. It's just like a .h file, except there's nothing in it, except for method declarations. So we have a class that we call it pencil. And we have, abstract method draw, abstract method sharpen, abstract method, all the behaviors that we're going to have. We take and include, or we shouldn't use the word include. We use the interface in a class, and we build classes, if we want, from multiple interfaces. So that gives us multiple line inheritance, which does not support it, which I mentioned before, not supported in the same way in C++, is supported in Java, which gives Java a little bit more capability. So it's an extension on the language. So in C++, if we had a C++ file, and we called it pencil.c++, and we included pencil.h that had all of the, empty methods in there, we would just use it to make sure that when we implemented it, we followed through the specification and we implemented everything correctly. It's more of a check on the programmer, just check on the environment. It's good programming practice, and once you create the object, all you have to do is include the .h file instead of the object code. It's a little easier in terms of the interface. In Java, none of that stuff actually exists. So instead we can have a pencil interface class. What else would be a pencil? So writing instrument interface class. We can actually kind of implement behavior that is of a writing instrument and also a pencil, or of a pen. We can make a hybrid pencil pen and include all of these different interfaces in it that are, basically going to extend the behavior a bit, make it a little bit more, extensible. And I'll talk about that. That's an entire lecture on its own, how to create interface classes and use them. Static represents the whole class, not a specific object. And it can only access static fields and other static methods of the same class. So if you wanted to create a method to modify static variable next, you would say, let's say for example, you're not going to use the constructor for this. You're going to say static, next ID is equal to 0. And then you're going to create a method, say, increment or assign ID or something. And in there, it would take and increment the ID. It would do the next ID plus, and then it would return it or assign it to something. You'd call that a static method. You use static because you're accessing a static, and it basically static is saying it's at the class level. Increment my ID instead of just incrementing it manually. So you would include the functionality inside of the method if you wanted to. Hardly ever see it in practice unless you're using a lot of static variables. So you're not going to see that many static methods. Some people, unfortunately, get confused with everything, and they make everything, they go abstract this, abstract that. And for the most part, the compiler is fairly forgiving. Like I left off public and private and everything, and it compiled it just fine for me. And it'll do this for you too. You can make everything static if you wanted to. It doesn't matter. It's going to work, but the logic's going to be kind of weird. So it's just someone looking at your program, they're going to go, how come everything's public static void? Which you see a lot of new people doing, because they copy examples off of the internet, and they go, everything's public static void. Wow. And then they go, well, the access method's wrong, that's why it's not working. And you don't really figure it out until you start doing inheritance, and you go, oh, I got to change that access method, otherwise I can't inherit from this correctly. Or, why is everything static? So stay away from using it. If you don't know what you're using, don't use it. Leave it out. If you leave it out, you can't make any mistakes. Unless it's absolutely required, and then you go find out, well, what am I supposed to be using? And then you figure it out from there. All right, so we're almost done. So we have the method body that appears after the header. Method invocations, as we've seen before. We've actually kind of seen this with the dot reference. Same thing as you do with variables, you do the same thing with methods. So invoke an operation on an object class using the dot. So this is the reference, or the P1, P2, pencil 1, pencil 2, dot, some method and the arguments that are associated with it. Static methods are outside of the class, so the reference can either be the class name, as we saw before, pencil, dot, next value, increment next value, or the object reference belonging to the class. So you can run it on the object reference P1, P2, or you can run it on the class. If it's a method, inside the class reference can also be omitted as well. Non-static method, the reference must be the object reference if it's non-static. You can't run a method on a class. It's not going to work. And you figure all this stuff out when you start making mistakes as well. You start seeing the error messages that come out of it. So. Overloading. Similar to C++, this is sort of like what we have with inheritance. And I'm going to just briefly mention the concept of method overloading, and then we'll see it when we see inheritance. So a class can have more than one method with the same name as long as they have different parameter lists. And this is how we're going to create our constructors next week. Because next week we're going to do constructors and we don't have deconstructors, so we don't have to worry about that. All we have really is the constructor. So public void set price, public void set price. This applies in Java outside of the constructor concept. So in earlier versions of C++, only the constructor could have the same name multiple times as long as it matched the name of the class. Java, you can make as many methods as you want with the same identical name, as long as they're carrying different levels of parameters, different number of parameters. If you do the same, you're going to get an error message. It's going to say, hey, that method already exists. But you can reuse the names all you want. Not such a good practice because it causes confusion, but it allows flexibility. And this actually leads into the concept of polymorphism, because you're running the same method, but you're giving it different parameters. So you're making it adapt, so you can send it a float, a double, you know. And you'll see this with print methods. So it'll say, give me the output. And maybe sometimes in some runs the output's a float, the output's a double, or the output's a string. And you just run the same method from the driver program, and you give it a parameter. Whatever the parameter is, it finds the correct method. And you don't have to even, you call it the same way, so you can have a pretty universal polymorphic method. In the implementation, you got a dozen of these suckers. They're all taking all the different values, but you're getting polymorphic behavior because you're getting one method that's responding to all of this input in the same way, and all the input's different. So that is actually an example of how polymorphism is supported in Java. Actually, it's done through overloading. So it's overloading methods. How does the compiler know which method you're invoking? Well, it looks at the parameters, actually. It determines by the parameters you've given it what method you're trying to call. So it compares the number and types of the parameters until one matches. Parameter values. So parameters are always passed by value, but they're treated passed by reference. And we don't have pointers in Java, so you don't have to worry about the pointer concept, which means we can send objects as parameters. They're really reference. Well, so is integer a, so is a variable, so is a data member. So parameters are always passed by value. Here we have public void method 1 integer a is equal to 6. And then we have, other stuff going on. When the parameter is an object, it is the object reference and not the object itself that's getting passed. Haven't we said it's passed by value, not reference? It's passed by value, but it's treated by reference. So the concept doesn't hold true. It's not the same as C++. There's no way of putting an ampersand in there, and there's no way of actually telling it to use it as a reference. It's built in automatically. So when you send an object, it's a reference to that object. It's not the object. It's not the value, it's the reference to the object. Which means you can send an object to a method, and it changes the object. The object life still exists. So we don't have that send it to a function, what happens when the function stays in the function. And we have that inside of methods that aren't using objects, inside of classes, but we don't have that in other instances. An object gets changed, it's changed. So here's an example of parameters as object references. Don't worry about it if you don't get this at this point. We're going to go through it again, another example. But here we have color plane, that gets sent as a value. And then we have painted red, paint color. So it's using that as an, and then we're setting it. So you can change the fields of the object to the parameter reference to the object has changed. So let's see. Yeah, well, hold on 1 second. I want to finish the rest of it, then we'll go. There's only like 3 slides left. I'm going to skip the explanation of the pass by value, pass by reference for the time in which we're ready for that, which is going to be when we start talking about constructors, because we can send one object to another object, and especially when we construct the object, and we can pass it by reference automatically, so we don't have to do anything special. Okay, so just to summarize, we looked at this already. The main method gives us our main concept of our driver program. System locates and runs, as we've seen in the example, the main method for the class. And it runs the program from main. So we still have the main concept. That was what we had in create pencil, you remember. Other methods get executed when called by the main method. And it must be public, static, and void. Main never returns anything, which is interesting. Point to make, because in C++, I don't know why, they always tell you, have a return a value, integer main. Where is it going to be returned to? In concept, it should really be void. So in Java, it has to be void. So it's static and void, public, static, void. If you leave it out and just write main, by default, it's public, static, void. So, which means it's public, it's accessible at the class level, and it doesn't return anything. So, which is the best of all worlds, if you think about it. That's why everyone puts public, static, void on all of their methods. And then you realize, oh, it's just changeable by anybody and accessible by anybody. So it's non-restrictive. So, main method getting the input from the command line. As we've seen in C++ and Java, and we saw this in our example, this will take our command line arguments, parse it, put it into an argument string. And we have the same concept that we have in terms of parsing command line arguments in C++. Same concept applies in Java. So there's a lot of similarities in terms of the programming language syntax between the languages, which, if you know C++, it's really easy to learn Java after that. And actually vice versa. Should be better, easier. So when running the program, the Java command, I can take Java space, a bunch of parameters, and then the name of the file. That stuff will actually work the same way as we do with C++. And greetings. Here's going to take argument 1, argument 2. And we're going to see an example of this when we talk about system output, system I/O, which is going to be next week as well. So we'll see that one. And then the last one to kind of reiterate the point of the modifiers of the class. So the class itself now has the same rules as the methods, has the same rules as the data members, which refers to the public, abstract, and the final. Hold off on using anything but public right now. Because when we talk about inheritance and we talk about interface classes, I'm going to discuss all of this stuff in a lot more detail. But right now, for the purposes of creating Hello World and all of your small classes, make everything public. What public does is it makes the class itself runnable and accessible outside of the class. When you say it's abstract, you can't make instances of abstract classes. And when people start getting, abstract syntax, public, abstract, void, and they start putting all that stuff on there, then they make it so the program doesn't run. You can't make an instance of a class that's declared as abstract. It can only be used as an interface. So abstract final, you can't make subclasses out of final, which means you stop the inheritance from going on because you don't want that class to be inherited. So final is very restrictive. Can't be subclass. Abstract, no objects of abstract classes can be created. All of these abstract methods are implemented by the subclasses. Otherwise, the subclass must be declared abstract also. Public is what you're going to use right now. It's going to make everything available. Without this modifier, the class is only accessible within its own package. So you can actually leave out public if it's in the same directory and you're not using a package, because packages are directories in concept. So, and I'll talk about packages in a future lecture as well. And the note on the bottom, normally a file can contain multiple classes, but only one public one. And the file, which is wrong, as we actually saw when they had 2 public ones. We just did it like earlier. So, and the file name and the public name should be the same, theoretically. So you're only supposed to be able to put one public class in a file itself, so, for good programming practice. But although the rules get broken all the time. So, okay, that's enough for our first full Java lecture. So next week I'm going to talk about system I/O, system input, system output, creating more sophisticated classes, and I'm going to demo the Eclipse. I believe I'm going to start using Eclipse next week as well. I'll show you how to create a project in Eclipse because it's a little tricky actually. You probably could figure it out on your own, but well, I'll go run through that as well. So see you next week. Lunchtime.